now we are going to start with the chemical properties of the alkynes. So I have few properties for you, so just look at the board. These are the addition reaction, polymerization, oxidation and acidic nature. I am going to prove all those properties in front of you by taking few examples. So the first, we will start with the first reaction, that is the addition reaction, right. So the first thing, by looking at the board, must be striking your mind that what is the reason that it shows an addition reaction. See, the reason is that to show an addition reaction, a compound must possess an extra bond, right, and we know that it also possesses pi electrons, and these are not, they don't have one extra bond, they actually have two extra bonds because they possess triple bond, and out of that triple bond, one is sigma and two are pi bonds. So that means they can show the reaction at two stages like this. Suppose I have alkyne. Now what happens? It turns into alkene and then it turns into alkane, because here it has triple bond. So when it adds certain substance, it changes into a double bond compound and then finally into a single bond compound. So that means it will show, definitely it will show a reaction at two stages. At first stage it will form alkene and the other stage it will form an alkane. So now I am going to show these addition reactions, that means I am going to add these substances. So just look at the board what actually the product we get after adding them. So the first is addition of H2. So this is my alkyne, that is acetylene, or common name, or you can say by IUPAC name it is ethyne. I am going to add H2. And we know that addition of H2 to any compound is actually a reduction, right? And I am going to carry out in presence of reducing agent, say nickel, or I can take platinum, I can take palladium, any of that, right? So what is going to happen? This H is going to attach to the carbon atom which bear a bond, right? So now it will turn into CH2, because one H will add into this, bond will become double and we will get an alkene, right? But we can also further carry out the reduction because it again possesses an extra bond. So what I am going to do is, I am going to add more H2, again a catalyst is used, or a reducing agent, what we call it as, is used, and what happens? It forms CH3 and CH3. Likewise, this H1 gets attached to here and we get the product, that is the ethane, right? And you know that if I wish to stop the reaction at this particular stage, like if I want to add a hydrogen to a triple bond compound and I want my reaction to stop at this stage, I can actually use a catalyst, that is the Lindlar Catalyst. What is that? It is sodium in liquid ammonia. So if I use that, the reaction stops at this place. That means it forms the alkene. Otherwise, if I go on adding, definitely I am going to get an alkene. So this is the first addition, that is the addition of H2. The second, I am going to add water to it. So this I have acetylene. Please remember the common name, it's very important, because whenever you get a paper or a question related to it, to make you to make a question tricky, what they do is they use the common names, and what you do is you are so familiar with the IUPAC names that you just skip learning the common names. So keep in mind that the common name for ethyne is acetylene, right? So this is what we are doing is, I am going to add water to it. So as we know, this is positive and negatively charged ion. So again it is going to attach, but here as the carbon carries the same number of hydrogen, so it can attach to any of it. And what will happen? CH2 bond will turn into double and it will have CH and OH. So do you think by looking at this compound that I can add more H2O? Yes, we can do it because it possesses an extra bond now. So again I will be adding water. Again, when we add this H and OH further, what happens? We actually obey the Marconis Rule. What is that? I think you remember, because we did in alkenes as well, that when we add certain substance, the negative part attached to the carbon of the unsaturated system, which bears less number of hydrogen atom. So as you can see that in this case, this carbon bears less number of H. We won't be calculating this OH H into that, right? We need a free H. So it has 2 and it has 1. So that means the negative part is going to attach to this and the positive to this. So what we get? We get CH3, bond becomes single, CH and OH and again OH. Do you think this compound is a stable compound? No, two OH cannot be attached to a same carbon atom because we know that water is a stable compound. So what happens in this case? The one water molecule gets eliminated actually, and what do we get? We get CH3 and it turns into aldehyde, CHO. That is, we have the ethanol. So this is what actually formed when we add water, right? Third, I am going to add an halogen acid. So this I have again acetylene. So again a positive and a negative part, and I told you that negative part according to Marconis rule attaches to the carbon atom of the unsaturated system which bears less number of hydrogen atom, right? So as they both have possess the same hydrogen, so you can make an attachment to either of, right? So suppose I am doing it this way. So what I get CH2, bond becomes double, and I get like X gets attached to this. Now we can add further because it possesses an extra bond. So in this case the negative part is going to attach to a carbon which bears less number of hydrogen, that means to this one, and hydrogen to this one. So what becomes? CH3, bond becomes single, CHX and X. So this is the final product. The third is we are going to add an hypohalous acid. Suppose this is my acetylene. I am going to add HOX. So as we know, it actually breaks like this. So bond will be double. One gets attached here and one gets attached to here. And further we can also carry out the same thing. OH, again OH, single bond, CHX and X. Again the water molecule gets eliminated and you get the compound. I'll write the name of the compound here. So I'll get CH X2, or I'll write in this way, X2 CH single bond CH. So this is what we get. Next I am adding sulfur. So let's see, this is my acetylene, I am going to add sulfur. In this case I am going to take two acetylene molecules. So it will turn into a compound, famous compound, that is called as thiophene. So this will be formed. And likewise I can do it for ammonia. I can add ammonia actually. And again the two molecules like this, and they will be forming a compound. What is the name of this compound? I told you when we were discussing the classification of organic compounds. It is nothing but the pyrrole. So this is what is the addition reaction. So I think it's clear that why the alkynes can undergo addition reaction. The reason behind that, they possess the extra bond. Second is polymerization. What is polymerization? Polymerization is actually a process in which the smaller molecules, or we can call it as monomers, they get attached to each other forming a giant molecule that is called as a polymer. So here it can show a polymerization actually, like if you take 3 acetylenes in the presence of copper and you heat them red hot, they will change into a benzene. They will change into a benzene. So this is what is the polymerization. So now the third property, that is the oxidation.